Lesson 13. JD here. Today we step outside our program and talk to the internet. jdBasic ships with a built-in HTTP client and a JSON parser. Two functions are enough to consume almost any modern web API. HTTP.GET string fetches the response body. JSON.PARSE string turns that text into a structure you can read like a map. Let us fetch the current weather for Heidelberg from a free public API. That is the raw JSON response. Curly braces, key value pairs, nested objects. Readable, but to use any of these numbers in our program we need to parse it. One line does the job. There. 3 live values, pulled from the air. JSON parse string returned a structure that behaves exactly like the maps you saw in Lesson 6. The current weather key gave us a subobject, and indexing into that gave us each field. Notice we did not write any parser code, no string slicing, no manual hunt for commas. The library handles all of that. Your job is to know the shape of the data and read what you need. One more example. Let us hit the GitHub API to look up a user. Live data from a real API, in a half dozen lines. The shape of the JSON dictates what keys you read. The rest looks like any other jdBasic code. A few quick notes for production. HTTP set timeout of n seconds controls how long to wait before giving up. The default is 10. HTTP.STATUSCODE returns the response code from the last request, so you can check for 200 versus 404. And there is an asynchronous variant, HTTP.GET async string, which returns immediately with a task ID so your program does not freeze while waiting. We will see that in a future lesson. That is HTTP and JSON in jdBasic. One function to fetch, one to parse, and the rest is just reading a map. Next lesson, we put on the engineering hat. We compile a jdBasic program to a native Windows executable, learn how strict mode catches type errors at compile time, and measure the speedup. Until then, keep coding. Bye.